Hello, hi. So in this question, basically we'll focus on criteria B, and this is question number 7, 32 marks question. So what we are doing is investigate the relationship between the number of squares inside the rectangle between two exponential functions. Okay, so there is a video over here. Let's see. This is one exponential function. This is the second exponential function, and these are the squares between the exponential function. The height of the rectangle is related to the position of P and is increases for each stage. So as you increase P over here, stage 1, 2, 4. Now each stage the x coordinate of P will increase by 1 unit. So this is how the height is increasing. You will investigate the relationship. Now this is important over here. We should know what we are doing actually. So do watch the video carefully. You will investigate relationship between the number of squares inside the rectangle as the stages progresses. Okay, so we will need to know or how the number of squares are changing with respect to stages progress. Okay, now this is given. This is a animation over here. This is what we can do is drag the slider to see how the squares are added. So the first function is gx is equals to half to the power x and fx is equals to 2 to the power x. This is stage 1. So in the rectangle you can see how many boxes are there. Now if you increase the stage 2, these are the boxes over here. Now stage 3, stage 4 and 5, so on. Okay, now the first information that this is 14 units in the stage 3. Show that the height of rectangle is 14 units. In your working you must use the laws of exponents. So in this is important over here. This is what is mentioned over here, that in your working you must use the laws of exponent. And which stage we are looking at? Stage 3. As we know that this starts, P is 4 over here, x coordinate is 4 over here, and we know it starts from 2. So I'll write down x coordinate at stage 3 is 4 and x coordinate at stage 1 is 2. Now if I see, let's suppose if I start with the function fx is equals to 2 to the power x. Okay, so what would be f of 4? We are looking at stage 3. So yeah, so at that point this is 4. Stage f4 would be 2 to the power 4, which gives you 16. And stage 1 would be f of 1, which gives you 2 to the power 1, that is equals to 2. So what is the height? So height equals to stage 3 y value minus stage 1 y value, which gives you height equals to 16 minus 2, which gives you 14 units. Okay, so this is your first question. I have explained in well detailed over here. I have written all the stages over here and all the steps possible over here. Okay, now let's go to B part 7b. Write down the missing values. Now if you observe the pattern, what is happening over here is that it starts at 4, then it goes to 8, then 16, then 32. So if you see, every time you are multiplying it by 2. So, and if you observe carefully, the function gx and fx are also in the powers of 2. Gx is in the powers of half and fx is in the powers of 2. So with this, I can write down this would be 64, then this would be double of 64 times 2 is 120. Clear? Now describe in words two patterns for S. So over here we need to be very careful how we are describing. So how to describe, or you can say patterns for S. So I write down pattern for S. So I can write down the first pattern, that it's, you can say, the number of new squares are power of 2. Second, the ratio of any two consecutive term is 10. True. Yes. So if you observe carefully that the number of squares are power of 2, number of new squares basically are power of 2, the ratio of any two consecutive term is constant throughout the table. So this is what you can write down. Other things, other options are, you can write down this, I'll copy over here. The number of new squares are even numbers. Just try to explain it in terms of mathematical notations, mathematical property, or you can say all the numbers are divisible by 4 or multiples of 4. You can say all the numbers are divisible by 8 except the first value, or the number of squares at stage 1. So this is how you can express in different ways the pattern, whatever pattern you observe in the table. Clear? Okay, let's move to the D part. Determine a general rule for S in terms of N. This is important over here. Determine a general rule in terms of N. Now we know this is a geometric sequence, and we know geometric sequence is A r to the power n minus 1. This is what we start with. So for the given values, I'll write down A equals to 4, r equals to 2. So general rule is, now make sure we write down in terms of S and N. Okay. Now first I write down general rule, then I replace the values in my general rule accordingly. Okay. I start with first is 4, then 2 to the power n minus 1. Okay. Now this can be further simplified. I'll simplify this. 4 can be written as 2 square. So I'll write down this is 2 square times, I'll just copy this if it is possible. Yeah. Okay. Further I can simplify this. We know when the bases are same, powers, in case of multiplication, powers add. So using the laws of exponents over here. So this will give me 2 to the power, if you see n minus 1 plus 2, so it would be n plus 1. Okay. Now over here. Now if I substitute n equals to 1 over here, what do I get? 2 to the power 2, which is 4. So if I substitute 1, I'll get 4. If I substitute 3 over here, so 3 plus 1 is 4. So 2 to the power 4 is 16. So if you substitute 3 over here, you will get 16. So now what we are substituting is n, what we are getting is s, that is number of squares. So we write down s equals to 2 to the power this. Now I'll write down, always communicate properly. What does s represent? Number of mu squares. And what does n represent? Is the stage. Clear? Done? Now verify your general rule for s. Now verification is most important thing over here. How do we verify? Make sure whenever we verify for the values which we have written in the table, not for the values. There is a difference between test and verify, these two command words. Test is always for the values which were already present in the table, and verify for the values which are not there in the table or you have written. So if you see, the stage 1, 2, 3, 4 values were already given in the table. So I'll verify only for 5 and 6. And always verify for at least two values. For at least two values. So correctly substitute S is equals to. Now I'll write down for stage 4. And before that, in case if I have to write down my general rule, I copy this and I write down over here. General rule is this. Now for stage 4, S is equals to 2 to the power. Again I write down over here. Simply use copy command over here. I'll replace 4 over here. Sorry. 4 plus. Which gives you 2 to the power 5 or 32, basically 2 to the power 5, which is 32. Okay, now for stage 5, again we do calculation and I'll do 5 plus 1, which gives you 2 to the power 6, which is 64. The value 4 was already given to us, stage 4 32. So we'll use for stage 5, sorry, over here, and we'll write down this as 5 plus 1, sorry, 5 plus 1, and this is 64, and we'll write down over here 6 plus 1, and this is stage 6, which is 2 to the power 7, that is 128. Clear? Now the last line is important over here. The values for number of mu squares using my general rule is same as written in the table using the pattern. This part is important. What happens in criteria B question generally? For all your calculations and everything, student gets criteria B marks. Basically, you get marks for all your calculation. But what student loses out is on the communication. So this is important over here. Now this question is the most scoring, and if you decode the pattern how to answer this kind of questions, you can surely get full marks in your criteria B questions. So always remember what you are supposed to investigate, figure out, and these are the answers you need to give, or you need to include answer for each and every pointers. That is, predict more values and record this in the table. Describe in words two patterns for column T. Determine the general rule for T in terms of N. Test over here, test your general rule for T. Verify and justify. What happens is there is a difference between verify and justify. Okay, that is equally important, and ensure that you communicate all your working appropriately. So last pointer is covered when you show each and every step and you communicate your mathematical understanding to the examiner in your paper basically. So last pointer is covered. Now let's go with step by step. First pointer, predict more values. We are looking at this part, predict more values and record this in the table. So we have to predict more values and we have to record this into the table. So the first column was already covered in the previous question. So I'll just continue it from there. This is 64, this is 128. Now there is further one more line over there to do fill up this also. 7, this is 256. Okay, now observe the pattern over here. This is 4. Now this column represents the total number of squares, that is T. What is the total number of squares over here? Now this is 4, this is 8, 4 plus 8, 12. Then 12 plus 16 is 28, 28 plus 32 is 60, 60 plus 64 would be 124, 124 plus 128, so 120 plus 120 is 240, 240 plus 12 is 252. Now 250 plus 250 is 500 and this would be 508. Clear? So till stage 7, this is what you are getting. So we have done predict more values and record this in the table. First part is done. Now they have given you this last column over here. Okay. Now this column they have given you is for a reason. Okay. So that you can figure out how the differences are increasing or something. So that you can figure out this part. Now let's start with the second. Describe in words the two patterns for column T. Okay. Now I write down the pattern for column T. Okay. Now what is the pattern? Now describe in words two patterns. So you have to include two patterns over here. What is the pattern you are observing over here is one of the pattern can be written that all the values are divisible by 4. Yes. Or you can say multiples of 4. Yes or no? So all the values in column T are multiples of 4. Okay. What else you can figure out over here is even number. So I write down are even numbers. Is there any other thing which you can think of? If you see now from here to here, the increase is of 8. Okay. Sorry. Now from 12 to 28, the increase is of 16. Now this is increases of 32. This is increases of 64. So you can say the values in column T are increasing by 8. Then you can write down after 8 is 16. Sorry, 16, 32, 64, dot dot dot, so on. Yes. Okay. So whatever you can figure out, whatever pattern you can figure out in column T, but try to explain it using mathematical notations or mathematics basically. In your explanation, there should be some mathematics involved. Okay. Now the next part, what we are supposed to do is determine the general rule for T in terms of n. Okay. Now if you are familiar with something known as sum of geometric sequence, because if you see the total numbers is basically sum of the terms in the geometric sequence. Yes or no? Because the first term is 4, second term is 8, so the total number of square is 4 plus 8, which is 12. Now first term is 4, second term is 8, third term is 16. If you add all the three stages, you will get 28. So basically, you know, 4, 8, 16, 32 is a geometric term, and if you keep on adding all this, what do you get? Geometric sequence. Yes or no? Now the good part over here is, now to write down the general rule, always observe what is given to you. So I'll start with what is given to me is the total number of squares in stage 1, which is 4. Now total number of squares in stage 2, which is 12, which is 8 plus 4. Now what is 4? 4 is the total number of squares in stage 1, T1. Okay, so I can write down this as 8 plus T1. Now T3, what is given to you is T3 is 28, which can be written as what is the previous term? 4, 8, now 28, already you had 12, yes, and 16, okay, 16 plus 12, which is equals to basically 16 plus the number of squares in stage 2, that is T2. Okay, now if you observe carefully the why I have written this part, whatever is given to me, I have written everything whatever is given to me. Sorry, this goes in subscript. This also goes in subscript. Yeah. Now observe over here. Term 1, term 2, term 3. So your next term depends on previous term. So this kind of formula is known as recursive formula. So we need to write down recursive rule for this. So how do we write down recursive rule? Recursive rule is always related with in terms of n, connecting it to the previous term, that is, now I know there would be something plus t n minus 1. Okay, this is what is happening over here, sorry. Okay, because if you see the next term, how do you get next term? In previous term, that is previous total number of squares, you add something. Clear? Now I try to connect with my term 1. Always observe with this part, term 1. Okay, what is given to you is 4. Now look at this part. This can be written as 4 into 2. Now this can be written as 4 into 4. Now, and this I can write down is 4 into 1. Now you will say, sir, over here we can also write down T0. Yes, T0 you can write down because at stage 0 number of squares are 0 only, which is 0. Yes. Now if you observe carefully, this is something 4 into 1, 4 into 2, 4 into 4. What should be the next step? What should be the next step? That T4 should be equals to, how much is T4? That is 60. 60 can be written as 28 plus 32. So I'll first write down 32 plus 28, that is your previous term. So again I write down 32 plus I can write down this as T3, which I'll copy it from here. Now if you have figured out, this is 4 into 1, this is 4 into 2, this is 4 into 4, this is 4 into 8. Now if you observe carefully that I can write down over here 4 into, now what I am multiplying is over here 1, 2, 4, 8, 16, all these are powers of 2. Now stage 1 the power is 0, stage 2 the power is 1, stage 3 the power is 2. So stage n the power would be n minus 1. Very good. So I'll write down this as n minus 1 and this goes in, sorry, power, this bracket close. Now this becomes my general rule. Now if I want to explain this, I can explain. Always it's better to explain where Tn since the total number of squares in stage n. Okay, general rule done. General rule. Okay. Part. Now if I want to make my answer little beautified, I'll do this. Now comes is our test. Testing general rule. So I'll test my general rule. Now always remember that there is a difference between test and verify. Please make a note that we test for the values which are already given in the table. So we can test for n equals to 1, n equals to 2, n equals to 3 or n equals to 4. So in simpler words, n less than equals to 4. You can test for any values for n less than equals to 4. Less than equals to 4. This is for your explanation. I am using this notation, or you can basically use mathematical notation over here. Now I'll test it for stage, let's suppose 2. For stage 2, n equals to 2. Now in my formula, what do I write down? T2. First I don't know, T2 would be 4, that is bracket 4 times 2 to the power 2 minus 1 is 1, bracket close, plus T1. So now if I just write down properly, this would be in subscript, this also go in subscript, and this goes in power. Okay, so what is the formula for this? Sorry, at T1 the total number squares are 4. So what do I have is 4 into 2 8, 8 plus 4 equals to 12. The value of T2 can be seen in the table. Okay, this statement is important. How you are testing? What is the evidence that your testing value is correct? I can see the value that the total number of squares in stage 2 is 12. And let's test it for one more value. Same process you need to repeat for stage 3. Your n is 3. Now if I copy everything over here, this is 3, this is 2, now this is 2. So this would be 4 into 4, which is 16, and T2, which is already calculated over here, 12. Sorry, what I did. This is T2, which is 12, and this gives you final answer 28. Now I'll again put up this sentence over here. This is important. This will give me marks, communications marks. So I'll not avoid this. Done. The testing part is done. Now I'm just bolding this part so that the one who is checking knows everything where I've done. Now testing part is done. See, the 4 pointers, 1, 2, 3, 4 pointers are done. The last and final pointer to earn full marks. Verify and justify your general rules for T. Verify, verify. इसको general. Okay. Chalo. Now over here, whenever we verify for the values which you have written in the table, or the values which are not there in the table. So we'll verify for the values greater than 4. That is 5, 6, 7, 8, 9. But it's good that you verify only for 5, 6, 7. Either of these 3. Take any 2 values, because then you can give evidence that you can confirm your verification is correct in terms of what we say, in terms of the values already written in the table. Okay, now verify. So I'll verify for stage 5, that is n equals to 5. So I'll again copy this everything. Now over here I'll write down T5. Now this would be 5 minus 1, which is 4. Now this would be your previous term 4. Now 2 to the power 4 is 16. 16 into 4 is 64. In 64 you add T4. What is T4 already given to you is 60. So if you add 60, this gives you 124. I'll write down the value do one more verification, copy everything. Now stage 6, this is 6, now this is 6, now this is 6 minus 1, which is 5. Now you add previous term. Now this is 128. In 128 you add 124. So in this you get 120 plus 120 is 240, 240, so 252. And the same can be written now that the value is verified. Now add 1. Hence my general rule works for all the values of n. We have tested, we have verified. Now we can say that our general rule works for all the values. Clear? Okay. So now justification. Justification or justify is different than verify. Remember, this command words are different. Now, how we are supposed to answer or how we are supposed to justify our general rule. So it depends from question to question how, or it depends, you can say ki, what is the investigation given to you. So currently if we focus on what's investigation given to us, so we'll try to justify our pattern rule that is correct using a different justification. Justify is means that you give a different justification that your pattern is correct. Now in this regard, if you remember how we started this question, so this question was all about, if you recall, if I take this question as an example, is all about, if you see, that is I can justify the same rule with using the concept of area of triangle. So justification is that from the pattern how you are getting the values, you use a altogether a different approach or different formula or different way to get the same thing. That comes in justification, and justification is very important over here, because if you score full marks in justification scenario, justification tag means under the justification, what we say is under the justification heading. Now if you score full in justification heading, which means your verification, testing, communication and all everything in that particular criteria B question is correct. Remember that. So that important is justification. Now how can we do this? If you remember, I can see that this is area of a rectangle. So if I take the area of a rectangle, so rectangle height would be the value at P when the x coordinate is 4. So that will becomes the height in the function, that is 2 to the power 4, which is 16 in this case. And what is the width of rectangle? Width of rectangle is 2. Okay, so what is 16 times 2 is 32. Now if you remember, we are looking at only the green part. So this remaining 4 rectangles are missing in this. So I need to remove this area of rectangle. Yes. So this is how you can do it. Okay. Which means if I generalize, let's suppose if it is stage 3, the value of P over here, that is your stage 1, this is stage 2, this is stage 3. So if we take stage 2, now stage 2, the value of X is 1. So value of X coordinate at stage 2 would be over here. Stage 2 would be in this case 1, 2 over here. That is 3. Now 2 to the power 3 is 8. So if you see, the height of this rectangle is 8, width is 2. So 8 into 2 is 16. But from 16, if you subtract this 4, you get 12, which was the pattern over here. The total number over here, 12. Yes. So this is how is there. Yeah. Now, so what I'll do is for justification, I'll use this scenario. Let's suppose I have already done this part. So I'll use this. I'll just write this down. So using my general rule for stage 3, that is an equation of T3 is this, which means the total number of squares are 28. Okay. Now I'll use the concept of area of rectangle. Now, if I say area of rectangle, so what is area of rectangle? Length into width. Yes. Now in this case, if I write down area, which is a length, so width is 2, length is the height of the function. Yes. So what was the function? Fx. Yes. Okay. Times 2. Width was 2 minus the 4 rectangles which were at the bottom. Now, how do you write down this? Area is equals to, what is fx? 2 to the power n, or x. This is written 2 to the power x. So, but we'll write down in terms of n. So, I write down 2 to the power n. So I write down this 2 to the power n into 2 minus 4. So this 2 to the power n goes in power. So if I simplify this, I can write down this 2 to the power n plus 1 minus 4. So 2 to the power n plus 1 minus 4. Yes. Now, sorry. So what is 2 to the power? We are looking at stage 3. Value of n is 3. And what is the x coordinate over here in stage 3? Stage 3. So this is 3. If I go over here, the x coordinate is, stage 3 is this. This is stage 1, stage 2, stage 3. The x coordinate is 4. So we'll remember this because this is how it is related to. Over here, I'll write down at stage 3 x. Okay, so this will become a is equals to 2 to the power 4, which is 16, into 2 is 32, minus 4, which gives you 28. I'll just, okay, and same value got from, same value instead of v, I'll use I got from my, hence I can say justified. Clear? Done. Now if you answer your question this way, I am going to give you guarantee that you will score full marks in your criteria B, that is question number 7. Now if you look at the total marks, this alone question F part was of 22 marks, and if you look at the complete question number 7 is of 32 marks, which means 32% of your entire paper, total paper weightage. So that's how you are supposed to answer your criteria B. If you observe, if you understand your investigation, if you explore your investigation properly, and if you answer each of the pointers, you will get full marks, and this will help you to improve your score, overall score. You can easily achieve 7 if you get good marks in question number 7. That is exactly, that helps you to score what you want. Perfect 7. Okay, so I hope this video helps you and guides you how you're supposed to answer question 7, that is criteria B, in your MYP Mathematics E assessment. Thank you for watching this video. Bye bye. Take care.